Why insects in Australia are bigger than in the rest of the world. Have you ever heard of the giant water bug? It's a type of insect that can grow up to 3 inches long and has a bite that can be as painful as a rattlesnake's. Or the giant huntsman spider. It's the largest spider in Australia and can have a leg span of up to 12 inches, 3.5 centimeters. If these insects sound terrifying to you, you're not alone. But why are insects in Australia so big? Well, in today's video, we'll be answering that very question. We'll be taking a look at 5 reasons why they get so big, and with that, more horrifying. Number 1. Climate. First off, Australia's unique climate plays a crucial role in shaping the size and behavior of its insect populations. The continent's vast landmass spans a range of latitudinal zones, from tropical regions in the north to temperate areas in the south, offering diverse habitats for various insect species. The prevailing warm and relatively stable climate across much of Australia provides favorable conditions for insect growth, reproduction, and overall ecological success. Insects, like all cold-blooded organisms, are actually ectotherms, meaning their body temperature is primarily regulated by the external environment. Therefore, temperature directly influences their metabolic rates, developmental processes, and reproductive activities. This means that in warmer climates, insects are obviously more active and their metabolic rates increase, leading to accelerated growth and development. As a result, they tend to reach larger body sizes faster. Additionally, the warm climate enables some insect species to have multiple generations within a single year. In regions with more seasons, insects may have limited time for development and reproduction due to harsh winters or shorter summers. However, in Australia's milder climates, certain insect species can produce multiple generations annually, leading to more opportunities for growth and large populations. Insects in Australia face fewer environmental stressors related to low temperatures, allowing them to allocate more energy to growth and reproduction. One example of an insect that grows bigger due to the warm climate in Australia compared to the rest of the world is the double drummer, Cicada. This impressive cicada is one of the world's largest cockroach species and can grow up to a wingspan of up to 13 centimeters in length. Number 2. Isolation. Secondly, Australia's geographical isolation plays into the larger nature of insects as well. Separated from other continents by vast expanses of ocean for millions of years, Australia has acted as a biological island for its native species. This isolation has led to unique adaptations and evolutionary processes, and some insect species have developed larger body sizes as a consequence. What isolation does is that it creates a barrier to gene flow between populations of the same species. As a result, different groups of insects in various parts of Australia have been cut off from one another. Over time, these isolated populations can diverge both genetically and visually, leading to the development of distinct characteristics. Let's talk about how larger body sizes are advantageous for insects in Australia, really quickly. One of the most evident benefits is the ability to store more resources. Insects with larger body sizes might have a higher chance of survival during times of scarcity, enhancing their ability to pass on their genes and contribute to the next generation. Number 3. Abundant food resources. Moving on, Australia's vast and varied landscapes hold a wide range of ecosystems, from dense rainforests to arid deserts, each providing a diverse array of food resources for its insect inhabitants. But why does Australia have such a never-ending supply of food for insects? Well, one of the primary reasons is the continent's ancient and relatively stable geology. Unlike other continents that have experienced significant tectonic and geological changes, Australia's landmass has remained largely unchanged for millions of years. As a result, ecosystems have had the opportunity to develop complex and specialized interactions between plants, animals, and insects. Also, plants form the foundation of most terrestrial ecosystems, and Australia is home to a remarkable diversity of plant species, many of which are found nowhere else in the world. The abundance of plant life ensures a wide variety of food sources for herbivorous insects, from leaves and fruits to nectar and pollen. In turn, these herbivorous insects provide a vital link in the food chain, serving as prey for insectivorous animals and birds. Another factor contributing to the abundance of food resources in Australia is the periodic occurrence of events like bushfires and floods. At face value, these events may seem destructive, but they are essential ecological processes that promote new growth and renewal. After a bushfire, for example, certain plant species sprout vigorously, providing an immediate surge of food for herbivorous insects. What's more is that Australia's diverse range of ecosystems, from the lush coastal rainforests to the arid inland deserts, allow the insects to adapt to a wide variety of food sources. Some insects are specialized feeders, relying on specific plant species for their survival, while others are generalists and can utilize a broader range of food options. Number 4. Absence of predators. As we previously mentioned, Australia's isolation as a continent has influenced its diverse ecosystems and unique species. But did you know that this has also led to a relatively low number of natural predators in some regions? Compared to other parts of the world, certain insect populations in Australia have experienced reduced predation pressure, creating conditions that can favor the development of larger adult sizes. One notable example is the absence of native land mammals in Australia, excluding bats. Most land mammal groups, such as carnivores and ungulates, are not native to the continent. The introduction of invasive species like foxes and feral cats in more recent history has had a significant impact on native wildlife. But prior to that, many insect populations evolved without the pressures exerted by mammalian predators. In the absence of significant predators, some insect species may have been able to allocate more energy towards growth and reproduction rather than investing in defensive mechanisms or anti-predator behaviors. As a result, individuals that can reach larger adult sizes might have a higher likelihood of survival and reproduction. Number 5. Evolutionary arms race. In the vast and diverse ecosystems of Australia, where a heap of insect species coexists with a wide array of predators and prey, the pressure to adapt and survive is intense. As a result, some insect populations in Australia may have experienced evolutionary arms races, leading to the development of larger body sizes as an advantageous survival or predation strategy. Let me explain. In an evolutionary arms race between insects and their predators, the basic idea is that any advantage gained by one group is countered by an adaptation in the other. For example, if a certain insect species becomes more adept at escaping predators through enhanced speed or agility, the predators may respond by becoming faster or developing better hunting techniques. In the same way, if an insect species evolves better camouflage, it might experience reduced predation, prompting its predators to develop enhanced visual abilities to detect them. In response, the insect species may evolve even more effective camouflage, and so the cycle continues. One example of this evolutionary arms race between insects and their predators in Australia involves the relationship between the caterpillar named the gum leaf skeletonizer and insectivorous birds, particularly the pied currawong. This caterpillar is known for its voracious appetite and its ability to consume large quantities of eucalyptus leaves, leading to the defoliation of trees if the population is not kept in check. To defend itself from predators, the gum leaf skeletonizer has evolved a unique adaptation. It feeds on the toxic leaves of certain eucalyptus species, sequestering the toxins in its body, making it unpalatable, and potentially harmful to predators. Enter the pied currawong, a common and intelligent bird species found throughout eastern Australia. These birds have actually learned to recognize the coloration of the gum leaf skeletonizer caterpillar and associate it with toxicity. However, the caterpillar didn't remain defenseless against the bird's aversion to its coloration. In response to the pied currawong's avoidance of its distinct color pattern, some populations of gum leaf skeletonizer caterpillars have evolved different color morphs. This applies to a larger size too. As we just said, insect predators such as birds, reptiles, and even other insects often rely on visual cues to locate their prey. In the evolutionary arms race, if an insect develops to be larger, it may be more intimidating to potential predators, dissuading them from becoming a target. This phenomenon, known as the predator intimidation hypothesis, suggests that larger body size could present a survival advantage in environments with limited predation pressure. And that's our video. If you have any comments or questions, feel free to leave them down below. And don't forget to hit that subscribe button and turn on notifications to stay up to date on videos like this. See you next time.